morning to all. Myself, Dr. K. Vishnu Prasad, Assistant Professor, Department of Conservative Dentistry and Endodontics. Coming to the material, we are going to see about the nanomaterials in endodontics. First, we are going to discuss about introduction to nanomaterials, process of nanomaterials in dentistry, synthesis of nanomaterials, classification of nanomaterials uses in endodontics and its applications. It is defined as a branch of technology that deals with dimension and tolerance of less than 100 nanometers, especially the manipulation of individual atoms and molecules. Nanometers is 1/9 of a meter. Nanomaterials are materials that have at least one dimension, length, width, height on the nanometer scale, typically ranging from 1 to 100 nanometers. A nanometer is 1 billionth of meter. These materials can be engineered at molecular or atomic level, which lead to unique properties and behaviors. Coming to its uses, it has better aesthetics, better imaging techniques, advanced antibacterial delivery techniques, improved structural strength, helps in sensitivity, biocompatibility, minimal invasive procedures when compared to other conventional procedures which we use in endodontics. It coming to the synthesis of nanomaterials, two approaches are done: top-down approaches, bottom-down approaches, bottom-up approach. What is top-down approaches? It is a traditional lithographic techniques are used to carve out nanoscale structures from bulk materials, such that from bulk materials it is made into smaller particles, and this method is commonly used in electronics industry to create nanoscale electronic components. Bottom up approach means it is involve three process: chemical synthesis, vapor phase synthesis, and self assembly synthesis. Chemical synthesis is nanomaterials can be synthesized chemically by controlling its reactions and allowing the atoms and molecules to form a nanoparticle, which like sol gel synthesis, co-precipitation, hydrothermal synthesis under these categories. Vapor synthesis means technique like chemical vapor disposition, physical vapor deposition are examples for these approaches. Self-assembly can assemble in order structures through chemical or biological process. DNA nanotechnology, for instance, uses the principles of base pairing to create precise nanostructures. Coming to classification, based on origin, it is classified into natural and artificial. Based on structure, it is classified into films, rods, nanocones, and nanoparticles. On basis of composition, inorganic zinc oxide components, iron oxide, titanium dioxide, aluminum oxide, bioactive glass. Metallic components which includes gold, silver, iron, copper, magnesium. Quantum compounds which includes cadmium sulfide, cadmium selenide. Functionalized with the drugs, photosynthesizer, antibodies, and proteins. These are the materials that have main body of one material and other particles or protein bound on its surface and enclosed in it. Coming to its clinical application, nanoparticles for endodontic disinfection or root canal irrigation, instruments and equipments, material modification which includes obturative materials, sealers, nanobiomaterials in endodontics, root and fill-in materials, repair and regeneration. First, in root canal disinfection, especially silver nanoparticles have potent antimicrobial properties. Used in root canal disinfection materials, nanoparticles can penetrate dental tubules and eliminate bacteria that are often inaccessible to conventional disinfection methods. Cytosine nanoparticles, it is an excellent antimicrobial, antiviral, antifungal properties. Proposed mechanism of actions which includes contact mediated killing that involves electrostatic attraction of positively charged cytosine with negatively charged bacterial cell membranes. They found that incorporating cytosine nanoparticles into the paste of calcium hydroxide could potentially be beneficial when using inter-appointment intracanal medication because of their ability to kill bacteria in short and long exposures. It is a study based on cytosine as a carrier and other antibiotic paste. This study concludes that addition of cytosine nanoparticle has a positive effect on effectiveness of this paste. DAP and MTAP produce significantly greater reduction in E. faecalis counts as compared to cytosine, irrespective of carrier use, saline or cytosine. It is this study is about efficiency of cytosine paste as an intracanal medication. In this study, efficiency of E. faecalis and Candida albicans are taken, and this study concludes that cytosine paste showed better efficiency in reducing viable E. faecalis biofilm when compared to calcium hydroxide after 7 days of intracanal medication in this in vitro root canal model. It could also significantly reduce viable C. albicans but was not significantly different from calcium hydroxide. Silver nanoparticles and root canal disinfection. First one, root canal disinfection challenge. Conventional root canal disinfection methods face limitations in effectively eliminating microorganisms due to complexities of root canal system and shortcomings of existing antimicrobials. Advantage of silver nanoparticles: it offers a solution with their wide spectrum antimicrobial activity, making them superior to other nanoparticular antibacterial commonly used in dentistry. Acceptable properties and low toxicity, which demonstrate acceptable antimicrobial properties and low cytotoxicity, ensuring the safety and effectiveness in dental application. Enhanced penetration and strengthening effect. Due to the nanoscale size, AGPNs penetrate deep into the root canal system, dental tubules, enhancing antimicrobial properties of endodontic irrigants and sealers. Moreover, they gradually increase dentin hardness in treated teeth. Versatile application as a carrier. It effective carriers for intracanal medication, promoting antibacterial effects, highlighting their potential in improving root canal treatments and its outcomes. This study is about elimination of microorganisms from root canal synthesis using laser activated nanoparticles. Background: effective elimination of microorganisms is crucial in root canal treatment to prevent infection. Utilization of laser activated nanoparticles have been used for root canal irrigation due to their antimicrobial properties. Findings include: after screening 51 studies, the systemic revealed that laser activated nanoparticles significantly reduce E. faecalis load when compared to conventional techniques, suggesting the potential as an alternative for root disinfection. Silver nanoparticles in intracanal medicaments. They have shown promising result as an intracanal medicament for removing E. faecalis as a resistant bacterium associated with root canal failures. Coming to its observative materials, bioactive glass 4,5S5. Nanometric bioactive glass particles of 4,5S5 is usually embedded in the gutta-percha matrix, immediate sealing properties when applied in form. Silver nanoparticles coated gutta-percha introduced by Dianet and Atta in order to upgrade the antimicrobial effect of GP, where the standard GP is coated with the nano silver particles. Demonstrate significant antibacterial effect against E. faecalis, Staphylococcus aureus, Candida albicans, and coli. This study is about efficiency of cytosine and silver nanoparticle coated gutta-percha for endodontic application. Root canal treatment is most effective treatment for irreversible pulp damage. However, it suffers the risk of failure due to micro leakage, the gutta-percha sealer tooth interface. Considering this issue, it is important to enhance the antimicrobial properties of gutta-percha. This study concludes that antimicrobial efficiency of coated gutta-percha was found in order 2% is great when compared to that of other. Live dead analysis along with the microscopic analysis provided evidence of bacterial membrane damage. Oxidative stress analysis depict the mechanism of antimicrobial of coated gutta-percha. Coming to sealers, gut flow fluid filled observation system. It is composed of finely grounded gutta-percha with polysiloxane and nanosilver. Further spread of bacteria is prevented by nanosilver present in composition. It is highly biocompatible. Coming to its QNPS NPS, which is nothing but a quaternary ammonium polyethylamine, long-lasting, stable, biocompatible, non-volatile antibacterial polymers. Incorporation of a standard temporary restorative material improved significantly their sealing ability and antimicrobial properties. Nano biomaterials in endodontics. It is a nano biomodified MTA, which is a size of 40 to 100 nm, reduced particle size surface area of about 4 times when compared to that of white MTA, enhancing hydration reactions. Initial setting time is 6 minutes, where even at low pH. Coming to biograde, it has excellent sealing, antimicrobial activity. It is the first repair cement endodontics with the nano-sized particles. Root and fill-in material, which is nothing but nanomaterial enhanced retrofill polymers, a novel root canal fill-in which provides superior bond strength and adaptability to the tooth structure when compared to conventional retrofill-in materials. Significantly reduce the micro leakage, demonstrating the ability to seal effectively, penetrate dental tubules of diameter 5 to 10 nm to provide additional nano retention. At last, I conclude that nanomaterials offer several advantages in the field of endodontics, the branch of dentistry that deals with the tooth pulp and tissue surrounding the root of the tooth. Here are the key advantages using nanomaterials in endodontics, which includes enhanced antimicrobial activities, enhanced aesthetics, enhanced mechanical strength, and enhanced effectiveness of the material into the dental tubules when compared to that of other materials. Thank you.